If you have no idea what electricity is and want to learn, then this video is for you. We will be making a very simple circuit made with scavenged parts. My intention is to try to make this as economical as possible. Now, you don't have to build this circuit at first, but I'll be expanding on it through a series of videos, so you might want to eventually start building it. Here is a list of materials you will need for this project. A sheet of metal, a metallic, whether it's aluminum, iron, steel, copper, anything like that. It will need to be about 16 inches by 14 inches, or 41 centimeters by 36 centimeters. You'll need some two-sided tape. Mine is Frost King tape. You'll need a soldering iron, mine's a Weller, and then you'll need electrical solder. You'll need a pair of scissors, a switch, toggle or push button. You'll also need a clip for a 9-volt cell. You'll need a 9-volt cell, and then you'll need a light bulb that is rated for either between 5 volts and 10 volts, and a socket that it fits in is optional. If you can get that, that would be great. Now you can get some optional tools. Don't need them right now for this video, but later on you may want them if you don't have them. Is a volt-ohm meter or a multimeter. It can be analog or digital. They're not too expensive. I've seen them anywhere from around $10 to, they can go all the way up in the hundreds for a really high-tech one, but you don't need that. $10 to $50. Anywhere in that price range will do okay. And then if you want, you can get a cheap oscilloscope. Again, you don't need that right now. The one I bought was for around $40. It's very small. So now, let's get into what electricity actually is. That's what this video is about, to explain to you what electricity is. And we'll use a very simple circuit to demonstrate it. As we go through this, we're going to need to know some terms. An atom. What is an atom? An electron, a proton, a neutron. A conductor, an ion. Electricity, direct current, alternating current, an electrical ground, a cell versus a battery, current and amperage, it's electromotive force, and voltage. So we'll start with an atom. An atom is made up of electrons, which have a negative charge, neutrons, which have no charge, and protons, which have a positive charge. Atoms are the building block of elements, such as metals, minerals, and gases, each having a specific number of electrons, neutrons, and protons in the atom that makes it up. Neutrons and protons make up the center or the nucleus of the atom. Electrons occupy fields around the nucleus called shells. Each shell contains only a certain number of electrons. Once a shell is full, the next shell out will accommodate the extra electrons needed to fill it. If the outer shell does not contain its maximum number of electrons, that atom is called an ion, and the material that atom makes up can be used as an electrical conductor because it can accept and release electrons from its outer shell. Electricity is the movement of electrons from one atom's outer shell to another atom's outer shell. As a model, think of a pipe as being a wire, and marbles as being the electrons in the outer shells of the atoms within the pipe. For electrons to flow, they need room to move from shell to shell. So one end of the pipe is open-ended, And we'll think of it as an electrical ground, where the marbles can drop out onto the ground, creating more space for other marbles in the pipe to move into. Now we need a supply of extra electrons and a way to get them moving. In direct current, we use either a cell or a battery as sources of electrons. A cell is a single unit that supplies usually around 1.5 volts to around 9 volts. A battery is a multi-cell cluster that can supply from about 2 volts to maybe thousands of volts. Batteries that big are rated in megawatts, but we'll discuss watts in another video. So we have our source of electrons, a cell or a battery. Now we need a force to move them. Volts are a measure of electrical pressure called electromotive force to move the electrons. Think of the marbles on the source end of the pipe being pushed by a small hammer. Therefore, a small force would be produced, or low voltage. Bigger hammers induce more electromotive force in our model, thus more voltage. So voltage is actually electrical pressure. Current is measured in amperage, or short amps, which is the amount of electrons traveling through the wire at any given point in a given amount of time. You could say you have a number of marbles falling out of the ground end of the pipe every minute or every second. An amp is an actual measure of the number of electrons moving along the wire at any point. There are two basic types of current: direct current and alternating current. Direct current is like one-way traffic. All electrons, or marbles, move in one direction. Alternating current is like two-way traffic. All the electrons, or marbles in our model, go in one direction for a period of time, then go back the way they came for a while. In this video, we'll be talking about direct current, or DC for short. AC is covered in another video. I mentioned the ground end of a pipe, or the ground end of a wire, earlier. A ground is usually the negative side of the cell or battery, but it can actually be the earth itself, called an earth ground. The negative side of the battery is called an electrical ground. In AC, the electrical ground is usually the earth. It's usually an earth ground. And grounding in either case is essential in electronics. Now to complicate things, if it's not already too complicated. In the real world, electrons are negatively charged. They repel each other. Like charges repel. If you look at a battery or a cell, you will find the poles marked plus and minus. The minus side of the cell has an abundance of electrons. The positive side is lacking electrons. So in reality, the current moves from negative side to the positive side of the battery. But in theory, we think of it just the opposite, current moving positive to negative. And that negative is the electrical ground. Okay, we're going to start this project by starting with the battery. We want to take the battery, we want to have this attached to the battery. Then we're going to take a roll of tape and we're going to cut off a strip about as long as the battery is. This is our double stick tape. And stick it on the battery. and you got to peel the backing off. That's always the hard part. And we're going to stick this, we want it to go this way. Now we're going to take our negative lead and we're going to tape it to the metal sheet. Leave the backing on one side. We don't need to double stick it. I want the battery to be stuck there good. And then just tape this right on the battery, right on the aluminum sheet. This is your ground. If you remember, the ground is kind of like a drain for the electrons to go from one side of the battery to the other. Okay, if you have a push button switch for this project instead of the toggle switch, you want one where you push the button once and it turns on. You see the fan running. And then you push it again and it turns it off. You see the fan stop. You don't want one where you have to push it in and hold it to stay on. If you release it, it comes off. You want it like this. You push it and it's on and it stays on, and then you push it again and it shuts off. Take this and we are going to solder this switch to this wire. There's a little hole. This switch I got out of a different piece of equipment, so it's been used. The little holes may be smaller than, because they'll have solder residual solder on them. Okay. Then we'll need to take our other wire on this side. Here's what I had done. The little tabs, they have little holes through them, and they were sealed over with solder. So I heated the solder up so it was liquid, and then I just poked the wire right through the little hole. You can see this one's sticking out. If you go too far, you're going to touch that. You'll short that switch out. So we want to try and bend him one direction or the other. And just bend him so he's not touching that other tab. Now we're going to take our switch, take it over here. We're going to keep this tight. I don't want it way out here or something, because like I said earlier, we are going to add to this circuit through these videos and make something rather useful, hopefully. Now this switch, I have some screws and a washer. I'm going to take them off. I'm just going to leave them on since they belong with it, but it doesn't lay flat. So I don't think it'll stay taped very well. So I'll take these off and hopefully not lose them. And then we're going to take some tape. Cut a little bit of tape. Stick it on the bottom of the switch, and then try to get the backing off. Came off pretty easy. And we're going to put this right about there. Now we're going to take our 9-volt battery, or 9-volt, I think this is a 10-volt light bulb. Doesn't really matter. I cut my tape. I'll put it right here. Put it right there. I can even put this wire in. There's a hole right there. Put right in there. Stick my light bulb down. And then I can solder that. Yep, he's soldered. And now I just have the other wire. This may already be attached to the board. We're going to attach it over there. Well, as you can see, let's turn our switch off. And then all we need is our tape to tape this right down to the board. You do not need to remove the backing. As a matter of fact, you don't want to, so it isn't sticky up there. I could have got that more in the middle of the tape. Now we can turn our switch on. And and there's our light, and we've made this simple circuit. Okay, the voltage goes from the negative side of the battery through the aluminum plate, through the light bulb, through the switch, and then back into the cell. But as we know, we think of it going the opposite direction. Okay, we have two schematics here. The first one that I've shown shows a wire connected from the negative side of the cell to the load, which is our light bulb. Then we have another schematic that shows there's no wire there. The correct one is the one without the wire, because we used the sheet metal as the wire from the ground to the load. It's called a common ground one. The second schematic is the correct one. Had that not have turned on, we would have to look for something touching this ground before it gets to the light bulb, say here on the switch somewhere touching ground. We'll see if we can do that. See if that works. It should cause the light to go off, I think. Yeah. If we touch this, if I can get that wire in underneath there so it's touching the switch. There. Goes out. The reason why it goes through here goes right to ground. That's called a short circuit. Remove that wire, you don't have a short circuit. An open circuit, there's a difference between a short circuit, that's what I just showed you, where you cut off the ground, you cut over the ground before you go through the light bulb. An open circuit is what the switch does. It opens the circuit. Closed circuit, it's a my switch is hard to flip there. Uh-oh, there we go. Uh-oh, what have I got? I got a problem now. Yeah, I think I got a bad, that was an open circuit. Okay, there's an open circuit somewhere. This guy isn't soldered good. I think that whole thing isn't soldered good. There. That was an open circuit. There's your open circuit, and there's your, and I showed you the short. So those are two problems that you could get with this circuit. It'll probably destroy the battery, so we'll shut her off and we'll get that fixed. Get that soldered back on there right. And that's your simple circuit. Okay, I forgot to add one thing to this in the middle, so I'm putting it at the end. And it is, what if you have your light bulb, but you don't have a light bulb socket for it? What are you going to do? So what you're going to do is you're going to take the plus side wire and you're going to solder it in on the light bulb on this little nub right here. And then you can take another wire and solder it to this outer part, and then solder it to, then tape it or solder it to ground. To solder these on, if you don't have any way to anchor them, is what I'll do. I'm gonna have to clean this tip here pretty soon. Is get a little drop of solder on the end of your tip and apply it to that base. You want to do it fast if your soldering iron is real hot. I'm going to tape it down just to hold it in place. So then we'll just tape this onto there for now. Tape that to there. And it should work. And turn it on. And it works either way with the bulb holder or without. So that's what I wanted you to know, that you can do that. If you don't have a bulb holder, just you could have soldered this directly to that, but I didn't realize I had that already soldered there. You don't need to bridge it like that. So, another thing I didn't mention, the reason why I'm taping these wires to this large sheet is because I haven't tried soldering them, but I do believe that this sheet will act as a heat sink and you'll never get it hot enough to solder the wire to it. You can try it, but I don't think you can do it. I didn't try it. The other thing too is when you're done with this project, you may not want to leave it all together, so you may just want to pull the parts off of the sheet. And that way you don't have to go and unsolder all of them. You just pull them off right out from under the tape. You may want to leave it together though once we're done with this. It's whatever your choice. I hope you learned something from this. I hope it was helpful. If you like it, please like and subscribe. Thank you for watching.